Okay, powerful tornado has winds which are stronger than that of a hurricane. It picks up an object and tosses it horizontally, a height of 2. Oh my god.
Like it's when you scrape on that.
Yeah. There's some like gesturing.
You are now down.
Okay.
Don't you even think about it.
So the object starts 2,000 meters above the ground. And then it gets tossed horizontally. And then it does this. And it lands 3,000 meters. Okay, and how much time does the object spend in the air before hitting the ground? So the thing that determines when it hits the ground is the y direction. So the displacement, I'm going to say down is positive. I'm going to go like this. The displacement in the y direction is 2,000 meters. The acceleration in the y direction is 9.8.
This guy just loves stuff.
Yeah.
Hey, get out of my backpack.
Jack, get out of his bag.
Most distracting cat I've ever come by. Here, look at it. Oh, there it goes. You just kind of Bye.
I'll be back. Okay, and then the initial velocity in the y direction is 0 because it went horizontally. So this y component is 0. So then you get the displacement in the y direction equals v naught t plus 1/2 at squared. And this is all in the y direction. So the initial velocity in the y direction is 0 because it got tossed horizontally. And then the displacement in the y direction is 2,000. That's supposed to equal 1/2 of 9.8 times t squared. So t equals, sorry, no one's yours.
Keep back out to it.
20.2 seconds. Okay, and then how fast was the object going initially when it was thrown by the tornado? So I know that the initial velocity in the y direction is 0. But so really what they're asking them for is what's this x velocity, right? And so because you know that it went 3,000 meters, you can just do the constant velocity equation because it's a projectile.
It's a projectile, right?
So then you just go Vx is equal to 3,000 meters in however long it was doing that for, which was 20.2 seconds. So the velocity when it originally like left the thing is 148.5 meters per second. And then how fast was it going when it impacted the ground? So I know it keeps this x velocity the whole time, but I need to figure out what the y velocity is when it hits the ground. So like when it hits the ground, it hits like this, right?
Mm-hmm. Right. You gotta find that.
I have to figure out the two components. There's this like Vx component, and there's this Vy component, and I gotta vectorially add those two together to figure out what the magnitude of this is. So to figure out the final y velocity, I could do v final y is equal to v initial y plus ay times t, where the initial velocity in the y direction is 0, and then it's 9.8 meters per second squared times the amount of time that it's going for, which is 20.2 seconds. You get 197.96 meters per second. That's the final velocity in the y direction. So if you draw a picture, you have a component. Oh my gosh. You get a component that goes this way with 148.5 meters per second, and you have a component. You have a component that goes
down the other way, right?
Yeah. What the heck? That goes this way at 197.96 meters per second. And so your answer goes from where you started to where you finished, right? Like it's whatever the magnitude of this is. So you use Pythagorean's theorem, and you go v is equal to the square root of the sum of the squares. 148.5 squared plus 197. Stop. 197.96 squared. So v is equal to 247.47.
4.6.